Today, we are going to talk about the Logit and Probit model, and please write it down because let me talk about the intuition, and then I will try to tell you why this is important, why Logit and Probit model is important. So, something that we did in the previous class and in the previous session, we were trying to deal with the multiple regression modeling, right? So, where we were expressing y as a function of various explanatory variables. Now what happened is, if the explanatory variable is qualitative in nature, which is taking value 0 and 1, then we have dealt with the concept of dummy variable technique. But in we haven't discussed so far is what happened is when the explained variable, meaning that uh, y or the when the y variable, which is the dependent variable itself, take value 1 or 0, so then what model we use. Now if you go back to our discussion, some of the important thing that we discussed is when we are doing multiple regression model, we basically assume something. First of all, the thing that we assumed is it is linear in beta. Number one, it can be nonlinear in x, because depending upon what type of function that we try to estimate, it can be nonlinear in x, but it has to be linear in beta. And why it has to be linear in beta? Because we want to have a single valued function for beta. Then the other thing which is there in the context of ordinary least square is x is non-stochastic, in the sense that because x is fixed, the distribution for beta is basically the distribution function that the error terms are following. So basically, if you remember the hypothesis testing that we did on the basis of null hypothesis, and again, what is the null hypothesis with which we started? We started with the concept of that null hypothesis is beta is equal to 0, and the alternate is depending upon whether we are going for one tail or two tail test. If we are doing one tail test, beta can be greater than 0 or it can be less than 0. And if we are going for two tail test, we are actually saying that beta is not equal to 0. So just to again repeat what I just now said, because these are the important concepts and I don't want you to forget this. First of all, when we are dealing with the ordinary least square, the important assumption is it is linear in beta, it can be non-linear in x's. Second, the basic assumption is we are doing a parametric estimation where we are assuming that the error terms is following a normal distribution. And because x is a non-stochastic, meaning that the when I am actually collecting x, that is fixed under repeated sample, meaning that if I'm collecting the value of explanatory variable, whether I'm collecting it from Greater Noida, or I'm collecting it from Delhi, or I'm collecting it from somewhere in UP, some other city in UP, that x that I'm collecting, it is kind of fixed. And on the basis of that x, I'm trying to predict the behavioral change or the variation in y, which I'm calling as dependent variable. And therefore, given that x is non-stochastic, the distribution function of beta follows the distribution function of the error terms, which in the context of ordinary least square is following a normal distribution. And therefore, all the hypothesis testing that we are doing under the context of ordinary least square is whether we are talking about one tail test or two tail test is dependent upon that nice looking bell-shaped curve. And I'm sure that you remember that we have this concept of what we call the area on which the critical region, what it means. If the numbers fall in the critical region, then basically we are saying that we are actually failing to accept the null hypothesis, and therefore we are going with the alternate. Failing to accept the null hypothesis means that beta is basically is not equal to 0. You know, it can be positive or negative or not equal to 0 depending upon one tail or two tail test. But if it is not falling in the critical region, I mean the value of beta, then we accept the null hypothesis, basically saying that we are actually saying that this particular variable does not impact my dependent variable. Now, whether the beta is falling under the critical region or it is falling under the acceptance region, that is something is given by the p-value of the t-statistics. For instance, when p-value of the t-statistics is, let's say, 0.05, what it is telling me that out of 100 times, 95 times beta is going to take value 0. Only 5 times it is going to take value not equal to 0. If it is 0.99 or it is significant at 1% level, what it is telling me that, sorry, in the previous case I actually told you the opposite, I think. If it is
yeah, exactly.
yeah, so in the previous case I just told you the opposite. Basically 0.95 means out of 100 times, 95 times I will find that beta is not equal to 0. Only 5 times I will find beta is equal to 0. If it is 0.99, then out of 100 times, 99 times I will find that beta is not equal to 0. Only one time it is equal to 0. And therefore, on the basis of this p-value, we decide whether to accept or fail to accept the null hypothesis. So that is where we actually started off with the concept of multiple regression. And going forward, we found something, there can be some aberration from this multiple regression, and we have dealt with that. For instance, one of the assumption was error terms has to be normally distributed, because without which I cannot do the hypothesis testing, which I just now mentioned on the basis of the p-value of the t-statistics. But if I find that the error terms is related, meaning the variance of the error terms is related with the x, then I have a problem of what we call heteroelasticity, and that is something we have already dealt with. If one of the explanatory variable is related to another explanatory variable, we have what we call the problem of multicollinearity, and that also we have tried to see or solve using the principal component analysis and other methodology as how we can control about the multicollinearity. These are the things which again we have done. The third thing which I've said in the class is it might also so happen that the error terms across cross section and across time series may also be related, and that is something we can figure out by looking at the Durbin-Watson statistics. And I also mentioned in the class, if your Durbin-Watson value is between 1.75 to 2.25, then you don't have to worry about the value of the Durbin-Watson. So basically it is suggesting that there is no presence of autocorrelation. However, if the Durbin-Watson value tend to take closer to 0 or tend to take closer to 4, either you have a problem of positive autocorrelation or negative autocorrelation, depending upon which extent your Durbin-Watson value is taken. And in that case, basically again you have to re-estimate the model and divide both sides by the estimated value of the error terms. I think I also have mentioned about this in the class. Then I have tried to give you a brief overview of the dummy variable, where basically what we did was we tried to say that what happens if one of the explanatory variables become qualitative in nature. And to that extent, we dealt with few things. The first thing is what is the use of dummy variable. First use, what we have done in the class, if you remember, is whether there is any presence of structural break in the model. Now, structural break, the way I was trying to define was that I hope that you remember the example we were trying to talk about in terms of the GDP data, and basically we tried to test the idea that whether after introduction of economic liberalization process in India, which started in the earnest of 1991, whether there has been a change in absolute level of per capita income, or there is a change in the growth rate of per capita income. This is something you can actually test in the context of or using the structural break in the model using this dummy variable technique. We also mentioned that many times what happens is you want to deseasonalize the data. Why deseasonalize the data? Because if you are, let's say, a garment manufacturing unit, basically you want to see that what is the intrinsic demand for the garment that you are manufacturing. What I meant to say by intrinsic demand, basically I'm saying that it may so happen during some festive season, because people tend to spend more money, you see a certain fluctuation in the demand of your output. But basically, if I want to see that what is the intrinsic demand, I have to net out this impact of the seasonal factor. And that is something again we can do in the context of using the dummy variable. So ideally, if I want to, and this is for your understanding, if you want to, let's say, model any behavioral pattern, let's say there, so this one thing is I mentioned about the seasonal factor. The other thing I'm talking about the exogenous factor. Now please try to differentiate between these two. Seasonal factor is something which happens every season, every year, so this is something which is given. For instance, every season, every year, at the time of Diwali or at the time of Christmas, people tend to spend more money. So that is, I can think that is endogenous to the system. And why I'm using the word endogenous? Because I know that during the festive season, it is intrinsic in the behavioral pattern of any consumer to spend more money, right? But I cannot model this using when there is some black swan event. And black swan event is something which you cannot predict, which you cannot foresee, which you cannot model otherwise in your data. For instance, if I were to model that what is the impact of COVID, because COVID-19 has happened. If you look into the data, you will find that over the last 80 or 90 years, this kind of viral or exogenous shock, although you have event like SARS or let's say some other viral diseases, but in terms of pandemic, in terms of pandemic behavior which COVID is showing, I doubt whether you have seen such pandemic over the period of last 90 years. And therefore, we call this event COVID as something as what we are calling as exogenous, So let me try to give you one concrete example. Let's say that you are working for one of the big four companies and they want you to figure out, and you have got a project where you wanted to understand that, where you want to focus the, let's say, the sales figure. It can be any sales figure of any particular company. Now when they want you to focus, ideally what you should do is you first run the multiple regression. And how you run the multiple regression, you have to also control for the seasonal factors, because when you want to forecast, you basically want to tell the party that irrespective of the seasonal factor, what is the inherent demand for the product that you are manufacturing. Now in this model, so ideally you should first deseasonalize the data by incorporating the dummy variable. And once you deseasonalize the data, and I have shown you how you deseasonalize the data, so basically you take the mean value of the estimated sales figure and you add and subtract the error component that you get after controlling for the seasonal dummy, So once I get the deseasonal data, then again I have to run the regression on this exogenous factor, which I'm calling as either COVID, or it can be some. So COVID is taken as a negative external factor. There can be some positive external factor, which actually helps us to understand that in what way that particular event is impacting the sales figure of this particular um, output that we are trying to measure. Okay, so that is one part. Now in this whole story that we dealt, and in the context of in the context of panel data, what we have observed is, in addition to the cross-sectional dimension, you might also have the time dimension, and therefore how you deal with the classic pool data, how you deal with the uh, least square dummy variable. So basically you try to measure the characteristic feature of various uh, companies or various organizations. And we have also looked into the within transform model. And again, the intuition for within transform model is in what way I can actually improve my predicting power. So all the thing that we are doing so far boils down to one thing, which is how I can predict the value of the my dependent variable. So that is what we are doing. Now what was missing in this discussion, which we were discussing so far, is in this particular discussion we did not discuss that how we were going to do if my dependent variable is uh, qualitative in nature. So here I have the data in front of you. So let's say that I have this data, what I'm calling as smokers. Okay, so this data is basically whether if you are smoking cigarette, then the data takes value 1. If you're a non-smoker, then the data takes value 0. Hopefully all of you can see the data, right?
Yes, sir.
Okay, so now let's try to arrange the data. And what you will observe in this data, there are few independent variables, namely income, education, uh, so my dependent variable is smoking, which is now have taken a value uh, 0 and 1 depending upon whether I'm smoking or not. So this is my dependent variable, and I have this host of independent variable uh, which is, let's try to give it a different color. So these are my host of independent variable, and please note in this variable I have education, I have age, I have income, I have price of cigarette. Okay, so this PCIGS is basically the price of cigarette. Then I have two other additional variables, which are the interactive term. Basically these two variables are telling you that whether I am able to introduce non-linearity in the x, because what are my x, what are my explanatory variable, these are my explanatory variable, right? So I can introduce non-linearity either by introducing a polynomial. For instance, I can actually make it education square or age square or income square, or I can introduce a polynomial by in this case, as you can see, I have multiplied age with education. In this case, I have multiplied education with income. So these last two variables are basically interactive variables, which is basically trying to introduce non-linearity in the x variable. Okay, now let's try to load this data. And so let's try to load this data, and again I'll have to now share this, but First, let me open the EBUs and then let me share this. Just give me a second. Now, let me share this. Okay. Are you able to see the EBUs data? No. Yes. No.
No, sir.
No. Right. Just
Oh,
share your screen, and then what I do, I go to EBUs.
yes, sir.
Okay. So basically, what I had is, now as you can see, this age is my independent variable, education independent variable, age, education, these are my interactive variable, smoker is my dependent variable. Now let's try to tell you that what we are trying to do in the context of Logit Probit and how it is different than the ordinary multiple regression. This is different. So please understand, Logit Probit is a non-parametric. Out of many non-parametric model that you will be doing, Logit Probit is one of the non-parametric model. Now, why I'm saying that this is non-parametric model, because in this case, if I run an OLS, so basically what is my dependent variable? Dependent variable is whether I'm smoking or not smoking. So dependent variable is going to take only two values. Depending upon whether I'm smoker, or if I'm not a smoker, it will take value 0. If I'm smoking, it will take value 1. In what way it is different than the multiple regression that we are dealing with so far? In case of multiple regression, the y is a continuous variable. That is, it takes value between, ideally between negative infinity to positive infinity. Because when I'm doing the normal regression, basically the basic understanding of doing normal regression is my error terms is going from negative infinity to positive infinity. But in this case, my dependent variable is taking value only 0 and 1, and therefore the way I'm trying to interpret the coefficient associated with the dependent variable is basically the probability, because what is the probability that my dependent variable is going to take value 1, or what is the probability that my dependent variable is going to take value 0. Depending upon whether it is taking value 0 or 1, I am actually trying to interpret my coefficient. Now let's try to see that in this case. First, let's try to generate this equation. So let's estimate the equation and let's try to see what happens in the context of if I want to run a just ordinary least square. So ordinary least square is basically, you have this age, I have education, I have income, and I have price of cigarette. Okay, now if I do this, what I'm getting is this result. Now the problem in this result is how we were trying to interpret the coefficient associated with the linear regression function. The way we are trying to interpret is so if I'm a smoker, if the age increases by 1 unit, so as I become more elderly, the my probability of smoking cigarette, it is actually falling by 0.004%. So that is the way I am actually interpreting. This is, by the way, it is called linear probabilistic model, or LPM. Let me repeat what this is called: linear probabilistic model. Why it is linear? Because it is giving me a linear association. In this case, I am saying that whether I am actually becoming elderly, let's say from between, so right now I'm 47. If I actually become from 47 to 48, the probability of me the probability of me giving up smoking is 0.04. And let's assume that Kuldeep's age is 23, and even for Kuldeep, it is still telling me that if Kuldeep turns from 23 to 24, his probability is also going to, for quitting smoking, is also going to get reduced by 0.004%. Now that is a very wrong assumption, in the sense that as you become old, or as you grow up, you might develop various comorbidity, you might develop various other diseases, health diseases, and therefore the probability of quitting cigarette for a person, let's say, who is 60 years old, as he goes into 61, his probability has to be much more, as opposed to me and as opposed to Kuldeep. Are you getting my point? So the one of the biggest problem with the linear probability model is it is basically telling you that the probability is linear. It is going to impact, irrespective of age, the behavioral change or the pattern, whether any person is going to quit smoking or not quit smoking. Any question, guys? Likewise, whether I am, let's say, I am class 5, I'm actually stepping from class 5 to class 6, or I'm stepping from class 12 to graduate, or I'm stepping from postgraduate to PhD. The change, so in this case, again, for one additional year of education, the probability of quitting cigarette is given by negative 0.02. It is irrespective of whether you are actually, as you can very well understand, the probability of you quitting or not quitting is actually much higher if you are in the age group of, let's say, 16 or 17 years old. For instance, the first time I started smoking is when I actually went to college, and then of course I quit after some point of time. But what I'm trying to tell you is the probability of me quitting actually happened when I actually got my degree and I actually came back to uh, India. So basically, I'm trying to say that this linear coefficient might not be true, and therefore this is one of the biggest limitation of the linear probability model that we are talking about. And therefore you cannot, and again, why we are calling this as linear probability, or why I'm calling probability, because unlike in the context of your multiple regression, where the y value can take any value depending upon what type of data we are talking about, here y value can take only two particular value, namely 0 and 1, depending upon whether, and therefore it is a probabilistic function. And the other problem with this particular model is, because y is taking two specific values, namely 0 and 1, the error terms, because again x is non-stochastic, beta, the value of beta is again dependent upon the error terms, and here the beta is basically going to be heteroscedastic, because what is my original model? Original model is y equal to beta x plus u, and if uh, u is basically for the error terms. So what is basically error terms? It is y minus beta x, where x is the all the explanatory variable that I'm talking about. Now if y minus beta x is my ui, so you can see that ui can also take two value only. One is 1 minus beta x, which is when y is taking value 1, and 0 minus beta x when y is taking value 0. So therefore u is also not going to take value between negative infinity to positive infinity, and that is again one of the limitation of the linear probability model. So how you deal with when you have a problem, when you have this linear probability model? So basically we'll have to go for the logistic regression or Probit regression. I'm not going to go into the methodology, as in how you derive the Logit and Probit model. I'm here going to only clear the intuition, and if you have any problem in understanding the intuition, please ask me. So here, again, let's see, let's try to estimate the equation here. Let's say that I have smoke is my dependent variable, and I have PCIGS 79, I have income, I have education, and let's now try to use the Logit Probit model. And for that, what you have to do is you have to go to this binary Logit Probit. We will not going to consider the extreme value at this point of time, but let's try to intuitively understand what this Logit and Probit model is trying to say. So let me try to okay, smoke is not defined because it's a smoker. Okay. So let me try to, so this is my Logit model, and if I do the Probit model, so the difference between the Logit and Probit model is the the function that we are taking, so, but in terms of interpretation, both the interpretation are same. Now let's try to do the Probit model, because I've done the Logit, I've done the Probit. Now let's try to do the Probit model, and you will see that more or less this is going to be similar, ECIGS, and then education and income. So I just hang on. First, no. Let me. Now let me. So first. So we have done the Probit, and I think let me do the Logit. And again, you do the. I'm sure that you can see the screen now. And let me do the same thing here. And before we get lost, let me interpret the numbers. Income and PCIGS. So this thing, I have to go to this binary. Why binary? Because my dependent variable is taking value 0 and 1, and this is the thing that we are getting in terms of now please try to interpret this coefficient. So the coefficient associated with education is negative 0.0141. So the way, whenever you are actually dealing with the Logit and Probit model, please understand there are few differences in comparison to what we get to see in the case of multiple regression. First of all, as you can see, as opposed to adjusted R square, we are getting what is called McFadden R square. Why? In what way this R square is different from this other R square? Because basically McFadden R square is giving you the ratio of the number of corrected prediction, meaning that here basically we are trying to predict in terms of the odd ratio. I'll come to the meaning of the word odd ratio within a few minutes. So here this McFadden R square is very small, as you can see, because typically in the context of multiple regression you will see that the adjusted R square tend to be high, particularly if you are dealing with the time series data. Even if you are dealing with the cross-sectional data, this number is in the range of 0.2, 0.3, something like that. For time series data, this number is basically in the vicinity of 0.9. But in this context, because McFadden R square is different in comparison to the ordinary R square, in the sense that here McFadden R square is giving you the ratio of number of correct prediction over the total number of observation. So in this case, total number of observation is 1196, and this is basically giving you the ratio of correct prediction. Now, one way to argue is why this R square is so low, because here, as opposed to the multiple regression where Y is actually varying quite a bit in tandem with the X variables. Unfortunately, in this case, Y is not varying that much because Y is taking value only 0 and 1. And therefore, we tend to see the R square, or the measurement of R square as captured through McFadden R square, is so low. The second thing, the second difference you should notice here is, here we don't have this F-test statistics. You remember that if I go back to the ANOVA, in the context of multiple regression, what is F-test telling us? That whether Y hat is a better predictor in comparison to Y bar. Now, in this case, we don't have F-test. Again, why? Because here we are trying to look into this. Here the F-test is actually represented in terms of the Eller statistics. What is Eller? Log likelihood ratio statistics. What is basically log likelihood ratio statistic is saying? You see that here I'm actually looking into two data. One is log likelihood, and other is, this is the first log likelihood is unrestricted log likelihood. What it is basically telling me, unrestricted log likelihood is saying that I am including all the variable, including education, income, and the price of cigarette. What is restricted log likelihood? It is saying that if all these variables are 0, meaning that education is 0, income is 0, and price of cigarette is 0, then what is the restricted log likelihood? And this Eller statistics is basically the equivalence of your F-test statistics that we see in the context of multiple regression. So if Eller test statistics is significant, which we are seeing is indeed the case, because the probability or the p-value of the Eller statistics is 0.001. Basically, it is saying it is significant at 2% level, which means that unrestricted model, which means that I need to actually incorporate education, income, and price of cigarette while I try to predict the behavior of whether a particular guy is smoker or he is a non-smoker. Okay, is that clear? Now, so these are the two basic distinctions between in terms of looking at the statistics. And the third major distinction, and this is the what I would say the major distinction between the multiple regression, is the way we interpret the coefficient. Because in the context of multiple regression, the coefficient is basically called the marginal coefficient, where just few minutes back when I tried to run an OLS, basically I'm trying to say that the probability is actually increasing or decreasing irrespective of the education, or irrespective of income, or irrespective of age. So it is linear. But here this is measured in terms of odds ratio. So basically I'm trying to capture the non-linearity. In what way I'm trying to capture the non-linearity? Now please listen to this carefully. So what is the definition of odd ratio? So if I'm looking into the education odd ratio, basically it is giving me the ratio of one unit. So if this is the ratio of whether, so given education, what is the ratio of a particular person smoking or not smoking, so for instance, this negative 0.04 is basically trying to tell you that if I am in class, if I am, let's say, 10 pass out, if I am 10 pass out, then from class 10, if I am going to class 11, what is the odd for me actually quitting smoking? So The odd ratio is again what? It is the ratio of you quitting smoking vis-a-vis you not quitting smoking. So that is the odd ratio. Likewise, the the coefficient, rather than we are trying to interpret in terms of the beta coefficient, we are trying to interpret in the terms of the what we call is in terms of the odd ratio. Any question, guys? Please try to ask.
So in the Logit model that we, like you have said that when my suppose education increases by 1 unit, the coefficient actually shows by how much unit will my dependent fall or rise, or the relationship between the dependent and the variable will fall or rise.
Not the so it's a probability in the linear probability
It's the
model.
probability.
Yeah. So in the
Right.
linear probability, the way we are trying to interpret that, going by this example, let's say that this is not Logit, this is not Probit, but it's a linear probabilistic model. Then basically what it's saying, the probability of me quitting smoking is with one additional year of education. Now this additional year of education can be from MA first year or MBA first year to MBA second year, or it can be from class 1 to class 2, But all this is saying that with one more additional years of education, how much, what is the probability of me uh, trying to uh, quit the smoking, So that is the odd ratio, that is the linear probabilistic model. Yes. But in this case,
So, sir, if I
please
sorry,
ask.
sir, please continue. Also, my question is the probability. Can I say that with one additional year of education, my chances of smoking will go down by 4%? Is that a correct way to say it?
No, in this case, what you should say, that with one additional year of education, the odd of me quitting
The
smoking
odd
is,
of
like, now why I'm saying the odd, basically I'm looking into the that particular, means I'm actually considering that level of education, So this, so given my education, the odd is 0.04, meaning that uh,
okay.
given my level of education, what is the odd for me for losing the for quitting the smoking? So let me be quite specific. So how I am actually writing this, because if you look into the now how you compute the probability, that is more important, is from the odd ratio. Basically, if I look into this, uh, for that again I have to share this. So please write this number. Please write this number in your, because again I'll have to share you the, in order to how to you interpret this. Please rewrite write this number, because once I leave this, I will go to the another thing. So C is 1.07. Education is ये थोड़ा लिख लो. Then have you written all of this? Just write this. Have you written this?
Yes, sir.
Okay.
Yes, sir.
Okay. So basically, so this is the thing that we got in the context of the Probit model. That and I was trying to tell you that this is the odd ratio. Now, in what way this is different than the linear probability model? In the context of linear probability model, as Kuldeep was asking me, basically is saying that irrespective of my education level, whether I'm a postgraduate, whether I'm a graduate, whether I'm a class secondary pass, the probability is always linear. The probability of me quitting cigarette for with additional 1 year of education is going to be 0.04. Now you will notice, and this is as I said, that let me clear the intuition. In the way the Logit model is written, if you look into your any standard econometrics book, uh, this is basically written in terms of the probability. Now, in case of the logistic regression, the way you are actually computing the probability, because these are the odd ratio, right? So the odd of you quitting a cigarette vis-a-vis of you not quitting a cigarette for a given level of education. Now, please remember, I'm using the word for a given level of education. Let me write it down. So here, this is the odd ratio for you quitting a cigarette vis-a-vis you not quitting a cigarette for a given level of education. Likewise, this is the odd ratio for you quitting a cigarette vis-a-vis you not quitting a cigarette for a given level of income. So the moment I use the word for a given level of income, education and price of cigarette, basically it is telling you that unlike in the linear probability model, which is basically saying that it's a linear relation, here the relationship are dependent on the level of age and education and income, and therefore this is going to vary depending upon my education, depending upon my income, depending upon my level of. Now typically the way you compute the probability is as follow. Again, what is the probability? The probability, so in case of Probit, uh, the spatial values. So in case of Probit, I said these are the odd ratio, right? And in case of linear probability model, I said that this is the linear relation captured in terms of the probability. In case, now if I were to linear relation captured through probability. Now if I probabilities, okay, now uh, if I want to convert this odd ratio into the probability, how should I do it? So basically the formula is 1 over, this is the formula, 1 over and 1 plus e to the power e is my exponential to the power alpha plus beta x. Now it is really becoming a little bit complex. Let's say alpha, I'm just writing it in full form, plus beta x. Now so this is basically, now let me explain what is alpha. E is my exponential. This e is coming because I have taken a Logit and Probit model. In case of Logit, as I'm using the word Logit, let me use the word Logit here. This the formula for conversion is given by this, and I can actually, if you want to dig deeper as to trying to understand the mathematical formula, we can have a chat later. But for the time being, let me show you how you actually convert this. So what is alpha plus beta x? Basically alpha is nothing but the intercept, because when we write y equal to alpha plus beta, beta is what? Beta are this coefficient, and x are my education, income and price of cigarettes. So basically I have to convert this. Let's say that I'm talking about this particular gentleman or this particular gentleman who is a smoker, right? I'm looking into the third observation, and in the third observation I'm seeing that this particular boy, he has attained 15 years of education, his age is 28, his income is 12500 and his price of cigarette is $60.6. So basically what is basically beta x? Beta x would be this times education is 15 plus income times this one plus price of cigarette times price of cigarette times this one, right? So what is missing here is my alpha. Let's assume that alpha is, which is my intercept, alpha is, let's say, I think we did a mistake in the sense that I think this 3.303 is not 3.03. It's actually 0 followed by, and that we will see later. I think it was something like this, Anyway, so alpha is, let's say that alpha is.
So actually,
Yeah,
that it was written, it's e to the power minus
minus 6, right?
0.05.
Yeah, so that means there are 50 over here, and let's
Yes, sir,
assume
yes,
that
sir.
alpha is just randomly, let's take some numbers. I don't know what is alpha. So alpha plus beta x would be, so alpha plus beta
So alpha is 1.07.
okay, so intercept is, so this is my intercept 1.07, and so basically alpha plus beta x will become this plus this, right? So now if I were to convert this, if I want to figure out what is the probability of a particular person with this criteria, who is having an education of 15 years of education, who is 28 years of old, and who is earning income of $12,500, what is the probability of this particular guy smoking or not smoking? So the way to go about this would be, so this is my alpha plus beta x, so let's write this plus beta x. Again, what is x? X is my explanatory variable. So the formula for this would be, the probability, the way I actually calculate the probability here is 1 over 1 plus E. E is basically exponential, which is 2.71, right? 2.71 or 72 raised to the power negative of, this is the formula for the Logit model, negative of alpha plus beta x, which is again negative of 0.434. So this is okay. So I think yeah. So basically it's saying that for this particular guy who has attained 15 years of education, who is 28 years old, and whose income is 12500, the probability of him becoming a smoker or him being a smoker, remember what is the McFadden R is saying? The probability of him being a smoker is 40%. Okay, likewise, if I go here again, as you can understand, the probability will change. If I go here, the probability is going to change. So basically the limitation which was there with the linear probability model, is not going to be there with the Logit or Probit model, because here the odd ratio is with respect to a particular characteristic of the explanatory variable. Is that clear? So the probability is going to change depending upon which particular individual, which particular data point that we are talking about. And therefore this probability is going to be nonlinear, and it is going to take value between, as all of you know, that the probability takes value between 0 and 1. Okay, so that is basically